next year we will announce when the date is more set in concrete, if you might say so. We will have these final presentations where you submit a poster and jury that evaluates you. So to recap, at first on 16th November we have a short idea competition, just right, 3-minute presentation or 5-minute with questions. And after 3 months where you work on the idea, you have the final evaluation. So we have a large number of jury members and mentors. Some of them probably will a little bit shuffle around. So let's keep this list for a different meetup to go through. So the prize pool is up to 10,000 euros. So there is an asterisk, and you definitely should read the fine lines. Basically, it means that each sponsor has 3 tiers for each of them prizes. They can either give like this bronze tier, which is 1,000 euros, or the gold tier, which is 3,000 euros. And also that money will be like actually not a gift, but a prize. And these 500 euros, however, which you get after qualifying in the first part, will be meant for materials. And the register button is here. We have a lot of awesome partners. Probably some more will join because partner deadline is 30th of October. So we still have a little bit of time left. Otherwise, the most important part after the registration button are these 3 buttons. So the email button is if you want to get in touch with us. You can also use social media, of course. So Facebook and LinkedIn. We actually created LinkedIn page today, so it currently has 0 followers, I think. So you can be the first one. Okay, I will be the first follower, and then you can follow in our lines. So we usually post the same information on the Facebook group and on event. The screen is welcome to the first event. Māris Šinka, yeah, you can talk.
Yeah, it's your time. I think there was some sound kind of delay, but yeah, Mari, the floor is yours. It's fine. It's fine.
Yeah, because I didn't definitely hear what Matīs was saying at the end.
Okay.
I don't know if everybody else also.
How far did you hear? Which part was the last one?
About the LinkedIn.
Yeah, LinkedIn.
Okay,
I think the microphone was just like missing some words, but we will get sorted out.
That was it. I was after that announcing that you are the main star of this evening, and so here you are.
I just was wondering, maybe somebody has some questions about this event, so we can maybe somebody wants to ask you some before I start, and then we can start it.
And then we can ask questions about the 3D printing itself. Yeah, that's a good idea. Do we have any questions? I think currently not. Well, if at any point you have, feel free to type them in without waiting in the comments in Zoom, and we will answer them. Otherwise, Māris, here you are. We can go towards Zoom.
Okay. Thank you. Thank you, Matīs and the team for hosting this event. I will right now try to share. So, hello everyone. My name is Māris Šinka. I am a leading researcher at the Institute of Materials and Structures at Riga Technical University, and also a head of 3D concrete printing scientific laboratory that we established in April of this year. My presentation will be like an introduction to 3D concrete printing, and the outline of the presentation, what I will talk about. It should be written 3D concrete printing and challenges, because I will not cover 3D printing in general. Definitely the part with the modeling and slicing, that will not be covered in this topic, as I am coming from a field of building materials, so I will tackle this presentation and this 3D printing, concrete printing problem from a material side of view, not from robotics, not from modeling, not from calculation, but from the material side. Then I will show some documented structural applications of 3D printing with emphasis on structural. show some topicality in the industry right now, and show what we are doing at the laboratory in Riga, and what the industry is doing in Latvia in general, the 3D concrete printing industry, and show some examples that may help you in the process for the contest, for the 3D printing contest. So yeah, the first part will be more in general about the 3D concrete printing, and the second part will be more specific, probably for this event. The first half of my presentation, the information for this I have taken from this is the largest scientific conference on 3D printing. It was this was last year's conference. It's a Digital Concrete 2020, for the some of the slides, definitely there is no references to the original authors. So if you have any real interest in those slides and pictures, you can definitely email me, and I can give the information about the original authors, and definitely I can advise everybody who is interested in this subject to attend the next year's conference, because this conference happens every 2 years. So it's a Digital Concrete 2022. It will happen in the middle of summer in Longborough, probably. I believe, I don't know exactly, but I think it will be a hybrid event, but I don't know if it will be on-site and online. But definitely this is of course, it is more scientific conference, but most of the industry is also there. And for anybody who is interested in this subject, this is definitely a highly recommended conference to visit. If we start with 3D printing, here are some 8, or actually there are 9 different pictures with companies and universities that are doing some kind of 3D printing, so we should understand which kind of 3D printing are we talking about today, because we have, for example, the D shape here, which is producing these structures using powder bed technology. So in a powder bed, with the layers you jet in a binder, and then you have this like a really free form structure. But this is one way of doing. They were one of the first ones to do 3D printing, but this definitely is not the industry standard right now. You have some more traditional ways, APScore and other companies doing this, to use 3D printing as a formwork, or you can call this contour crafting. So you print the outer layer, outer structure of your wall, for example, and then fill it with traditional concrete. This is also a 3D printing. Some more unconventional ways from TU Braunschweig. This is 3D printed with shotcrete. So there are 2 robotic arms applying shotcrete to this steel mesh construction. So this is also a 3D printing, but definitely with some limitations and specialized 3D printing. Yeah? For example, ETH Zurich with their smart dynamic casting, this slip molds or mesh mold that was produced by a mesh that was produced by robotic arms, and then a human labor force was just applying mortar to it. So there are different ways that 3D printing is done, but we today will be talking about more about extrusion-based 3D printing. So this is a process in which a real free-form object is created from a digital file using a specially designed concrete composition and a concrete printer with an extrusion-based print head. Yeah, so we extrude the material layer by layer. As you know, there are several advantages to this fabrication method. So one of the advantages is definitely freedom of form. So we can produce these free form structures without the need of molds. there is definitely a advantage of automation of construction industry and optimization of structures, as you will see in later slides, how you can optimize your construction if you can apply the material to only the places that you need. And also probable CO2 reduction in the future. That's why there's a question mark, because like CO2 reduction, cost reduction, labor force reduction, these are all probable future significance and advantages. Because right now, all of these structures that you see here definitely require a lot of cement to be printed. So CO2 reduction is quite debatable here. Material waste reduction, probably if we would be doing this like all the time, only 3D printing, and we're very good at it, then the reduction, of course, from molds and material leftovers. But at this point, still, I would say that material reduction is still also debatable. So there are significances, but also there are you have to be careful with this, as this is a new emerging industry. There are a lot of claims in mainstream media about wonders that this technology can do. I don't know, print a house for under $4,000. No, it's not possible. Print a house in 24 hours. No. There's a large asterisk at the end when if you would Google the information or just dig deeper, you would understand why it is not as it's claimed by the mainstream media. But it's definitely a very significant industry that will play a role in the future and plays a role today. But here we can also see different types of extrusion-based 3D printing that's done by different universities. So here is from Danish Technological Institute. They are printing with this fast setting binders, where you can print really freeform structures. Or, for example, from TU Eindhoven, who is printing and applying this steel reinforcement at the same time, and creating these, for example, bridges that you will see also in later slides. Or, for example, TU Dresden, who is envisioning that 3D printing could be used to print like more regular structures using traditional methods, just with the print head at the very end of this building process. I will show right now a little bit different extrusion modes that is possible. So we can work with the stiff material extrusion, but this has some limitation. That buildability with this material is really great. You can build high, but there could be problems with the layering, and the problem with the pumping of this material and extrusion. There is a possibility to work with extremely flowable material, but then you have to have this fast setting material that is setting as you print it. And most commonly, and what we are using today, is this what you can call an oriented pressing. So you press the material upon the previous layer to get this like a more flat form for the stability, and also that the layers stick very well between themselves. Here, I think there are. I will see if the video will work very well. I think it's okay. Yeah, so you can see from TU Dresden, so this extrusion with the stiff material. So it looks really nice, but this is definitely not something that is being done in industry today, or you can work with a very flowable material. This is done by several companies that has these fast setting binders. But usually this is something in the middle with the material that is used for this oriented pressing. A little bit I will cover also about the reinforcement in 3D printing, because reinforcement and 3D printing are not very compatible, as you understand, in traditional concrete. So you first of all apply reinforcement, then you cover it with a concrete. Here, it's not that easy to do that. So there are several methods that you can do. First of all, you could do this external reinforcement, but this is definitely not something done regularly, because here the reinforcement is subjected to corrosion, and this is an expensive and really unconventional way how to apply reinforcement. One of the ways that is being used in a 3D printing is post-tensioning. So you print these different blocks. Actually, they are printed sideways. So yeah, and then flipped around, and then afterwards they are there is, like you can see here, this traditionally cast concrete. There is like a steel wire that's run through all of this structure, and a tension is applied to these wires, so it keeps the structure together. So it's one of the ways how you can apply reinforcement in 3D printing. You could have this reinforcement installed at the time of printing. This is, for example, done in TU Eindhoven and only some other places. So there is a small steel wire, but this does not cover all the reinforcement needed for these structures, because these actually post-tension and the reinforcement at the same time. This is for this structure, both of them are used. And then you can do these permanent molds or contour crafting that is actually done a lot more, done quite a lot in an industry. You have seen probably this, like a highest 3D printed building in Dubai. They had like 3 stories built by Episcore. There is this permanent mold system. So the walls are printed and then it's cast with traditional concrete. So the engineers know how to calculate it, and everybody knows that this building will stand in place. You need this reinforcement because concrete is really bad in tension. So you need some reinforcement to provide these capabilities. So we need to think about reinforcement quite a lot if we think about the structures that we are going to build. What most commonly, contour crafting could be the one that we will be talking and thinking about more in the context of the competition. Some challenges that is in regards to printing, to print head. So you can have these technical challenges. That's more of challenge with your G code. That is the one that is created after you have, first of all, you model your object, and then you slice it, and then you generate your G code. So either there's an extrusion rate is too slow. That's could be fixable quite easily. Extrusion rate too fast. Definitely there could be worse images of extrusion rate too fast, or you can get this tearing of the extruded layer. There are different ways as this tearing can happen. Either there is too extrusion rate is too low, or material is also possibly that it has started to set. It's also one of the ways when you can get this tearing. About the challenges in 3D printing, if you think about extrusion, so one small mistake accumulates really fast. So you have this one little mistake here, and you have this large mistakes afterwards. This whole structure can collapse from this one mistake. So 3D printing doesn't allow for a lot of mistakes, and also different ways how the material or your construction will fail. So either you can have material failure from yielding of your material at the lower ends, or this is like a buckling of your construction, so it's just collapses, but this is more connected to the geometry of your structure. This is more with your material itself. So either you have material that you cannot extrude, or you can have a material that is yielding at the lower levels, or it's buckling from the height of the structure that you have been building. So enough about negative. Let's focus on some positive aspects. And here was one interesting presentation where most of the structural digitally fabricated projects were compiled. So if you look at these years from 2014 to 2019, only 22 structural digitally fabricated, so 3D printed, mostly 3D printed projects were done in the world. So a lot of place for new projects, companies, innovations. First, which is a little bit like a starting point from for 3D printing, this was called the Future Tree. This was done partly by ETH Zurich, and the idea of this construction, this is not fully 3D printed column, but they had a task that they wanted something that could be calculated and could be calculated by the existing building standards. And one of the ways how to do it is to use traditional reinforced concrete. Here you can see the reinforcement, and to pour it into some form. And so they 3D printed. We will get back to the slide. So they 3D printed the outer shell. So they call it eggshell. So the idea is to print really thin layer of shell to use as similarly to molds in construction to formwork, but in this case the shell is really thin, and if you would apply all your concrete and just pour it in, it would collapse. So in this, the idea was to print the mold and cast the concrete in the same time. I think they went, in the end, they went with the idea to cast it in layers because they have this really fast setting concrete in Zurich that they are using. But anyway, this structure is like, you can say, partly 3D printed, because this is like a traditional reinforced concrete that is holding this tree wooden canopy here, and is calculated by existing construction standards, because it's really important in construction. Everything is standardized, and you will see later on what is happening if you don't have standardized construction. For example, here, this was one of the first bridges to be printed. This was done by TU Eindhoven with some industrial partners. So here, they didn't use standard reinforced concrete. So one of the ways how you can do this, they had some limited, but had some data about the compressive tensile strength of this material. So they built a finite element model around this data, and they had to validate their model. So one of the ways how you do it in construction, this is called design by testing. So you have to prove that your construction will hold the loads, and you have to do this scale model. It's not a large scale, it's 1 to 2 scale. So you have to build almost the same bridge, little bit smaller, and you have to destroy it. So this is a destructive 4-point bending test. So you bend your structure until it collapses. You achieve the desired data to validate either your model is correct or not correct. You can use the structure or not, but you understand that this is really expensive way how to make structures. If every structure would have been designed in this way, this is not a sustainable way how to do it. This is only for development of this industry. So yeah, one of the ways how this can be done. This is something more simple. This was done in Innsbruck. I think this was with the help of Baumit and construction materials company and university in Innsbruck. So the idea of this pavilion was that these are all separate elements that are self-supporting. So they are designed in a way that they are freestanding, and nothing else holds them but only themselves. And the idea that they are calculating, as this is not highly risky structure. So consequence class 1, it means that nothing too serious will happen if something will break. Okay, maybe this might fall to somebody, but so this is like a lowest level of consequence class. So you have less of a problem if something goes wrong. But anyway, the way how they designed it, so they used more material safety factors. So in construction, it means that it is anyway on the safe side. So we know how this material will behave, but we just take 2 times the material. So we know it will definitely hold everything that needs to be held here. And that is one of the ways how these constructions, 3D printed constructions, can be built and designed according to some local or national standards, building standards. And this is also one of the ways how you can do it. This is from University of Ghent. This is here you can see somewhat. This is definitely optimized structure. So this kind of structure probably is only possible with with a lot of molds. Definitely you can do it, but here 3D printing has shown its I would say best qualities, as this is free form. Every element is unique, and in this way they also have this post tension wiring here that is holding this construction here together. So yeah, we can have this optimized construction with 3D printing. I will now show also some projects that is more from the industry. Here were also you saw that this amount of structural projects, and here you can see that amount of projects worldwide definitely is on a rise, and this was 2018. Is the last year, so definitely in 2021 this curve is growing exponentially, of course. But you understand, if there are only 22 or I don't know 50 projects around the world, or 100, it doesn't quite compare with the actual construction going on in the world today. So growing rapidly, but still enough space for other companies, for students, for developers in this sector. Usually I look, we try to look at the latest projects that have been completed, or some news about them, because we cannot cover all the projects. So this was similar to this last slide that I showed. This is from TU Eindhoven with their industrial partners Weber Beamix. So they I think it was in September they completed this longest 3D printed bridge. So this was also done by designed by testing. So these elements had to be tested with these really large scale tests. And as you can see here, so this is like a casted element in this contour crafted form, and here are the places for the post tension wires to go in. So this is the way how they constructed this bridge with quite large span, quite large. Yeah, other way, totally different way. This was done in the middle of summer. This project was unveiled. It is an collaboration from ETH Zurich and Zaha Hadid Studios, an architectural film company. And Farj Holcim is a materials producer from this. So here they used very different methods. So these elements are 3D printed. I think this is with quite fast setting binders, quite free form elements. And the way how they this structure was being built, so they built this a wooden structure underneath it, and assembled all the elements and removed the wooden structure. and this is working as a clamped arch. So there is no mortar, there is no connecting elements in between. So this is working only the same way as an 12th century English church is working. So definitely a different way, different approach, not a conventional approach, but it highlights that you can have really, yeah, your imagination can run quite wild while thinking about the project and the things that you can do with this technology. More conventional ways, probably you all have seen these largest right now in Europe buildings, probably, or maybe somebody has built even larger right now. So buildings from Perry and their and Cobod printers. Cobod is a company that Perry has I think a minority stake in, but anyway, they are collaborating quite a lot and build these two structures in the spring and in this summer. So here, a lot simpler construction, layered extrusion, manually inserting some reinforcement. And this is done according to construction standards without design by testing. Nobody has built such a house and broken it. But in this case, and I am not completely sure, as I understood, they were using standards of unreinforced masonry structure here, but I don't have yet a confirmation of this. Totally different approach, a little bit off the topic of the 3D printed concrete, but of course we can print with different materials. As in the start of my presentation, I told you that concrete and cement is not the best materials when we think about climate change and CO2. You can work with the different materials in 3D printing as well. Here from a producer WASP, that is a producer of actually producing 3D printers, actually quite small, different kind of printers, small, larger, medium size, and these larger crane WASPs, and they show their capabilities by printing this a clay structure. So this is not a load-bearing structure. It's a clay structure that is filled with the rice husk insulation. So this is really a sustainable and probably climate neutral building. And the cost of this material is also not that high. But of course, the technology and is still quite costly to build in such a way. But 3D printing is helping different kind of materials to be put to be accepted in this construction industry, definitely. Some maybe more down to the ground approaches. I don't know if this company Brühl from Netherlands have achieved their goal, but last year they presented the idea of reconstructing an existing building. Here, the building itself is not 3D printed. So it's an existing building. It was from, I don't know, 50s or 60s. And the idea that they need to refurbish it, and they were planning to do it with such a printed elements. So here you have actually limited number of unique elements, some balconies, this. So here you can test all of these elements, and then you can build the whole house with such an elements. Definitely, and maybe more cost-effective, more time-saving approach to 3D printing by applying it to quite large scale. I think this is the last project. Not a lot of information yet about this, but from a company Extrusion in France, they just, I think, in the summer signed an agreement with the municipality of Paris for this longest 3D printed bridge that will be done for 2024 Olympic Games. Interesting how this will be achieved, probably with post-tension, but here probably some post-tension wire will run through. But yeah, we will see in the future. let's now look at how about Riga Technical University. So this is how it looked 12 months ago. So we had this incomplete 3D printer, gantry printer frame with very simple print head. It's a PVC pipe. We had one researcher working in this direction. Of course, others were working with materials, but 3D printing was not very hot topic in our university, and we had no industry support. And now, some 12 months later, so we established our 3D printing laboratory in 1st of April this year. Here is some opening video of our laboratory. So yeah, we finished our existing gantry type printer, built a new batch type print head. We'll be expanding this print head and attaching pumps and mortar mixers to it quite soon, as this project is continuing right now. We have been partnering with an industrial partner. It's a company Sakret. It's a quite big company in Baltic states. So it produces dry mixes for construction. And we have a industrial PhD student who is working and being sponsored by this company. And several other researchers and research directions have been started in our university. So a little bit how about the scientific or directions. So as I told you, so we have this one research direction that is done in cooperation with the industry partner Sakret. The PhD student is working on trying to see the correlation of printer and the mixture that Sakret is developing, how they are compatible. So looking at various variable parameters of the printer, like nozzle dimensions, different nozzles, different shapes for printing, different extrusion speeds, object shapes, layer heights, and testing different mixtures that the industrial partner is offering. Other research directions that our laboratory is right now starting. We are also into durability testing of these materials. So we have started it only in this September. A lot of information about the testing methods, probably not very useful for this presentation. But the idea is that we test how these materials, 3D printed materials, compare to casted concrete to regular concrete. Yeah, so we print the material, then we cast in the molds and see how their strength, how their durability differs, and whether or not this material that we are trying to print actually, for example, can hold a Latvian winter. And the last one of the last directions that we are working on, this is my scientific project. We are trying to use bio-based materials in 3D and in the construction industry with 3D printing. So in this case, we use the bio-based material is biological filler and mineral binder. Here is a material called hempcrete. It's made from hemp chives. It's a byproduct of hemp fiber industry and mineral binder. Here it's printed with simple hydrated lime. So this is definitely an interesting material to be working on. Maybe a little bit further from industrial applications as concrete, but something similar, as I showed, for example, as Wasp company did with their clay structure, something similar could be printed with hempcrete. So it has really unique this buildability. So it means that you can build quite high without adding any stabilizer. So if you print with concrete, you need special additives so the material doesn't collapse. Here with hempcrete, there are definitely some advantages of printing with hempcrete. Yeah, if you are into more of these materials, you can check out one of the articles about this subject that we did last year. This article was done last year. Yeah, and a little bit how it looks with the industry. So this is the last. Some weeks ago, we organized the first industry meeting in Latvia, because we as a laboratory intend to be as one of this, like a contact center for the industry, to activate to help everybody to join forces for this industry to become more active. What are the main here are the main industrial competitors now, like main industry that is working in Latvia right now. So the company Sakret, as I told, is building a dry mix manufacturer. Profab, Fab Control, more working on the printers or this software for printers. Company Constros, that is producing, well, still in development, but producing these ceiling panels from wooden wool and printed gypsum. So they are using printed gypsum to create these free-form ceiling panels. And there is a company 3D Tech. Maybe you have seen this green hanger that was in the background of Evia. She's a student working with this company, and they are based in Jelgava. Quite new company, so they are still working on this technology. But this they have bought a printer, it's called AMT, from a company in Russia that has had for some time have developed these printers, and so they have bought this printer and have good cooperation with the municipality, one of the municipalities in Latvia, and have good plans how this 3D printing technology could be applied to some municipal projects. We wish them luck, and then we'll try to cooperate with them as much as we can. So let's now look at the 3D printing contest itself. Here I gathered some of the limitations of the printer that we have in our lab today. I have quite a mixed feelings about these limitations. We discussed it with Māris that we need to have some frame for the students to be working into. But on the other hand, I don't want to limit anybody too much, because if you think about limitations, you might end up with really simple and uncreative structures. But anyway, you need to know these limitations, that they exist. But there are anyway, let's say, an asterisk to every of these limitations. So currently, we are working with this. This is a cement-based binder. There are no set accelerators, so it means it doesn't set very fast, which means you cannot get really free-form structure, that you cannot get any form that you want. This material has to take some time to set. That means if you print one layer upon another, it cannot go like 45 degrees and then just stand like in air. But it has some good mechanical properties. So when it cures, it reaches 40 megapascal compressive strength. It is very good, quite okay for construction industry. So regular concrete could be some 25, 30 megapascals. So, but this mixture is, and this mixture, what we will probably will be working is a mixture of the company Sakret. So good buildability, but medium set time. The one other limitation could be nozzle sizes. Here we can see that the 3D printed nozzles that our printer is using. So these are from 20 to 30 millimeters. We have some larger nozzles that is from steel. stainless steel, but I don't see a point of them in this competition. But it is possible to use, and as you can see, these are not very hard to make nozzles. So if we need something different for your competition object, probably it's not a problem to make some new nozzles. There are some limitations of the pieces that you can print, but it's currently. So I say currently, so these are the limitations of the X, Y, and Z axis. So 1.2 meters in this direction. X-axis is quite limited to 400. It's actually some 450 if we would stretch the limits, and the height is 844. But it's not like, and I have an asterisk here. The printer itself is currently on wheels. So if we have a surface large enough, we can move the printer. So, okay, it cannot print in one go, but if it needs to connect some different structures, it probably can print the next structure here if it is necessary. And also, as you have seen from the slides, there are definitely different approaches how you can do it. If you want to print your whole house in one go, okay, yes, you need a cobalt printer to do that. But this is probably not the aim of this competition that Māris is organizing. Here, I also showed some angle limitations that could be printed in one go. And again, here is an asterisk, because you can, of course, you have workarounds around these. If you want to print, for example, if you have one object that needs to be printed, you can, and you need this quite large angle for it, you can have something to support it at the bottom. Yeah, maybe you need to make some. Somebody needs to make some, I don't know, like a supporting structure from either polystyrene or something more recyclable from sand. We can do. There is I have seen such a printing where you are doing your mold from a sand. Yeah, you can recycle it definitely, and your structure doesn't collapse when you print it. So this is, all of these have some asterisks. They are limitations, but you shouldn't focus very much on these limitations, because you might end up with some not so creative objects. Here are some of the objects that have been printed. For example, say if you stack these layer upon layer, put some reinforcement here, pour it with traditional concrete, you can have different structures, interesting structures. Here are some models, and then the prints that the PhD student has been doing in celebration of the 1st of September or the Olympic Games, or this is like you have seen, so probably these like a concrete chair, and you print it sideways, and then you stack it up and sit on it. Yeah, one of the ways, for example, how this is an idea for a Christmas tree, leg for a Christmas tree. For example, if we cannot do this angle right now, we are just for example, this we are printing. Here is a one cylinder, and this is like a next layer. So it's actually quite full, and you don't need to this whole angle doesn't need to be left alone, so it can rest on 3D printed structure that has been printed at the same time. So different workarounds how you can solve these issues. Yes, and now we will at the very end we will look at different examples. These are examples that can be found on this Facebook group. It's called, yeah, you can join this group. I think it's one of the largest, and different 3D printed projects have been, you can see here, and definitely draw your inspiration from this Facebook page. So we are starting with some, and you can all find these. I don't have references for these either. I didn't want to put all the references. You can find all of these projects in that Facebook group. So if you have some interest, I think it was only the last 3 months what I could see some just pictures. So these are quite simple construction that definitely can be printed, not that hard. These, you print sideways. Probably you can fill it with traditional concrete, or probably some, if the structure is very well designed, even don't need to. These angles and rotation definitely can be printed. So this is a good way to start. Maybe let's say more traditional. This was from, I think, Czech Republic. So some freestanding examples. It's also something that can be done. It's a chair. Some reinforcement maybe is needed here for totally not to break, but this is something doable. If you can turn it around into maybe something more interesting, I'd say this is something to be looked at. Here, the idea of an arch, definitely you can see this is actually, I'm not sure what is a small bridge, probably some small bridge, and the arc principle of an arc is used here, so it holds itself in a place. So you probably not completely sure, but if you reinforce it at the end, so you don't need any extra reinforcement here or at the bottom if it is as an arch. This was, I think, also from Czech Republic. You look at it, it's like a 3D printed parkour park. But if you look from the top, you can see it's actually a contour crafted 3D print. So these structures are contour crafted, like only the outer layers are printed, and then it's filled with traditional concrete, traditional reinforced concrete. So a way to design and build it without the need of testing or hard calculations. This was from China. I think one of Mati's friends did this construction. It's interesting ways how you can do pavement. So if you can 3D print it, definitely some interesting patterns here you can see. If you print in this way, such large surfaces, and then in Latvia, the question of durability might come into place because you will have people putting ice on it, so it doesn't get covered with people will cover salt, so it doesn't get covered with ice. This will affect durability of your concrete. So there is some limitations, but definitely possible. You can see some 3D printed bench also at the background. Oh, I don't know how this was made, but you can imagine there are different elements that has been put together, something similar to what I showed in Innsbruck or other projects. And this is on the hard side of things. This is also from University of Ghent. Their, I think this is latest optimized bridge. This is something that I would not recommend doing for this competition, as here you need quite a lot calculations to design such a structure, and you need these post-tension technology to be used to do these large spans. So to do a large span with 3D printing, we it's possible to if it's possible to use standard reinforced concrete, then it's definitely a much more safe way to approach it. So this would be something probably too hard for this competition. Also, this structure, I was not sure of the context it was put in the Facebook group. Maybe there is some calculation how it can stand and be freestanding, but I would not suggest doing making something that can break and somebody can stand beneath it. This does not look very. Maybe if it is safe, it definitely doesn't give an impression that it is safe. So I would avoid something like this. Try to avoid roofs being made from 3D printed concrete, at least for now. And I think this is a really great example of creative approach, because here the actual 3D printed elements, they actually could be done maybe even not without 3D printing, because they are they are the same. Maybe some missed opportunity because there could be a pattern even with the different 3D printed elements. But anyway, they are separately printed such pieces that is put into this load bearing. It was metal or wooden, I don't remember, frame. And the idea is that you get this really great lighting object, and this is, I think, really great approach. This is not so technically hard to do. It's not a high structure to be building, but this is definitely a really interesting way. Or such a structure. Okay, these are not from concrete, but they could be. I think this was from clay. And I didn't read about the project, but it looks like it. I don't think that it's even. You can see there is a wooden structure and these clay bricks. So individually printed clay bricks, resting upon this wooden structure that I also think is not connected anyhow. So it's only self-supporting, and it's supported by its own weight. So really interesting structure that you can build. Okay, maybe this is not the greatest structure to be putting outdoors, because somebody can take out of one of your bricks, but definitely shows an interesting way how you can think about it, and that the limitations maybe are not actually the limitations. Or again, something similar to the future tree that I showed, because this is the same university, same laboratories from ETH Zurich. So yeah, using two printers at the same time. This is not actually right now possible at our laboratory, but if you have or know how to print such a large scale eggshell construction, you can have this. This was printed and casted at the same time, printed with the three different elements, and a post tension wire is going through this structure. This is definitely a very interesting approach. Okay, this has been done, but you can also get inspired by this. It's maybe not the extrusion-based 3D printing that I have been talking about, but something similar that can be probably can be used. Okay. That was the last slide of my presentation. Here is my email if you need to contact me at my university. And I will now stop sharing the screen. And do you have some questions?
Definitely. Thank you for the great presentation. For the questions, either raise your hand or you can write them in the comments and I will read them. For those of you who don't have microphones, looking at you, Mikus. Otherwise, I have a few opening ones that I collected somewhere. The first one is, are larger prints harder? Like, I suppose in the existing solution, you said that you can kind of stretch, like for traditional like plastic printers, if you print really large, like maximum build plate size elements, there is higher chance of failure. Does it also apply to concrete printing?
Definitely, because I think the question itself answers, because the larger your objects, the higher the chances. I think for everything. So
also height wise.
Yes, of course, definitely. So if you definitely the last second to last these small bricks, well, if you would fail 1 or 2 or 10 of them, it's definitely not that bad. But if you would have to print all of that structure in one go, well, every failure would lead to a total waste of materials and your time. So of course, smaller prints are better, but of course, balance. If you want, but there's a balance. If you want like 1,000 little pieces that you need to assemble at the end, maybe that was not the point. But also maybe interesting idea, yeah, to assemble it as from really small interlocking pieces that you.
I like that.
Yeah, why not?
That's a great idea. Okay, actually, the second question is like a follow-up, and it's what are the mechanical properties of 3D printed materials, more in regards to surface treatment? Do we need to treat it for it to be outdoors?
No.
Okay, it's already.
No. So this is, as I told, this is from so traditional cement. So it's ordinary Portland cement based, and I know. We shouldn't treat it with any special, but probably we should think the idea is like this. Concrete, okay, is okay if we leave it outdoors, but as I showed, if you would put some pavement, you know that somebody, janitor with the salt will come there and do his job. In Latvia, they do that. Okay, maybe if somebody from university campus will specially say that he cannot do that, maybe okay, we can save it, but there are some limitations. So and again, if you will design some structure where water accumulates, yeah, and like concrete is not totally frost resistant with enough size. So concrete has these freeze thaw cycles, so you can the water can go in it and freeze only for limited amount of times. So we can get these problems if we design it in maybe not the best manner. So yeah, it's not probably shouldn't be taken as a limitation right now, but something to be thought about maybe in the later stages of this contest.
Yeah, and there's a very good question from Krish Berscounts. It's probably for me. So, is there a predetermined place where outdoor structures might be placed, and then we can design structures within the context of the location, or should objects be universal in use location? So yes, there is a predetermined location. It's Latvian University campus, and it will be either at the front entrance or near the new building of Rakstu māja, probably a combination of both. When you receive the task set, so in order for everyone to be fair, all of you will receive the same package on the start of the competition at 16th of November, but we probably will have one of these Tuesdays, same time at 7 in the evening. We will probably have a meeting with Latvian University representatives who are developing this area, so they will give you some pointers and tips and what types of objects they are looking for. So currently, as far as we have talked with them, benches from different shapes are very what they are looking for. Also some shelters, because it's quite a windy area, but we already talked with Māris that shelters probably are a little bit stretch goal. We'll see. That's why we have up to 3 objects. So we want to create one that is really easily printable, one that is a little bit interesting, and third one that is probably a little bit more challenging. And Otherwise, yes, another question from Mikus. Once more, the info about the place of the event and registration missed the beginning. Oh yeah, I can do a quick repeat intro. I will share the screen right now. Meanwhile, you can type in more questions for Māris, because not always we will have him here present. So use the opportunity. Basically, you go to the website print concrete.com. Like hyphen is this domozīme in Latvian. I don't know the name. I think it's slash me now. Yeah, I hope you can see it. Yes, and there you can read a little bit more about the information, see the picture of Māris. There'll probably soon be a video of him, and see the mentors and all the other info. But most importantly, when you register, you click here. Basically, you type your name, surname, all the usual stuff. It's important to know from where you are, of course, and here is a part. So basically, you can participate either already as a team, if you know people you will work with. You can participate, you can say that you are looking for a team, and then below in the comments, you can say what type of experience you're looking for, or you can participate as a solo participant. So it depends if you want to split the price with others or if you don't need any help. But we do recommend that to join in teams. So maximum team number, I think, was 5 people. Here you also should mention your main skill. So for those who are looking for team members, we can kind of help you find out which people are available. And given that there is not like a set limit of places, but it's also not infinite. So there is a little bit of evaluation if too many people join. So if you can write 1 or 2 sentences, just don't get too broad. Just if you have had some experience with 3D printing, or maybe you can just show that you are super interested in this topic, and then say what you are interested in. So on student status, basically it's important because in order to pay the award after this second part of the event, we need 1 Latvian student in your team. So that's basically something. So if you don't have it yet, you can type in here where you are that you are looking for one, and we will try to find some Latvian student who is looking for a team to match you up together. Most important information, registration closes at 10th of November midnight. So you still have, I think, 13 days to make up your mind. Although how quickly you register is also something we have data on, and we take that into account as a motivation. So the quicker you register, the bigger are the chances that you will be in. Otherwise, we are super happy to have you here, and let's check if we have any other questions. Dash, yeah, Meiko, thank you. That Dash is the way. So print-concrete.com. Perfect. So if we don't have any questions, you can still write us either through the website or personally, and we will try to help you come up with the answers. So the next Tuesday at 7 o'clock, we will either have this kind of pop-up bench 3D modeling Blender exercise where you can try modeling organic forms in 3D software that is free, and or we will have a presentation from Latvian University. If they are ready for that, we will see. So that their meeting is on Monday, and after that we will see for sure. So most likely it will be the 3D modeling meetup, and Latvian University one will be later, but we'll know for sure on the weekend. Otherwise, you know the time, it's 7 o'clock, and there will be something about 3D printing. So yeah, I think we don't have any questions. Maybe someone has any closing words. Well, I think the only closing words is that you need to register if you want to join. In other words, thank you, Māris, and let's hope we can meet next weekend.
Yes, thank you very much. I will close the Facebook live stream, but if you feel like staying, you can of course stay.
No problem.
Yeah, maybe
if you
you
don't want to be recorded, you were